Okay, so this is a quick video. We're giving you a quick review of the half-life of iodine 131, our penny to beans activity. So we have some pre-lab questions here. What subatomic particles make up the nucleus? So I'm just looking for the particles that are in the nucleus. Remember, there are 3 subatomic particles in the atom, and only 2 of them are in the nucleus. What charges do these subatomic particles have? You can list those. The main forces that exist in the nucleus of an atom, we reviewed these. They are the strong force, the electromagnetic force, the weak force, and the force of gravity. The gravitational and weak forces are so tiny, they have almost no impact. The main forces in the nucleus holding the protons and neutrons together are the strong force, which holds everything together. It's an attractive force. And the electromagnetic force, which is repulsive in the nucleus, because the electromagnetic force is the one that, if you have 2 positive charges trying to get close together, it'll be repulsive, it'll repel. Or 2 negative charges will repel each other. So that's electromagnetic force. So electromagnetic is repulsive and the strong force is attractive. Why do atoms go through radioactive decay? Because the electromagnetic and strong forces are not balanced. And therefore, if the repulsive force is stronger than the attractive force, then you'll have an unstable nucleus. Half-life is the time, it's the time it takes for half of a material to decay into a daughter material, a different product. Also, half-life is the same for a particular radioisotope. So iodine 131's half-life is always 8.02 days, no matter how much or how little you have of it, or how many half-lives it's gone through. It's always 8.02 days. Where can you find the half-life of a lot of materials? Well, that would be on your reference table here. Not looking at the periodic table, but on table N of your reference tables, N right here, it shows you the half-life of a lot of different radioisotopes. The nuclide is like here, and the half-life here. It also tells you the decay mode, and it tells you the symbol, mass number, way of writing it. I should also quickly mention that table O, which is after table N, gives you the names, the notation, and the symbol for the different radioisotopes. I'm sorry, emission particles. Okay. So those are the pre-lab questions. Then for the actual lab, you would have taken a cup of pennies, thrown them, any of the ones that ended up heads are the ones that have become daughter cells. So they've become xenon 131. So you'd remove the heads and replace them with xenon atoms, which we gave you beans for. So here's the nuclear equation right here. And here's what we actually did. The model of it is right here, right? So then you have your data for each half-life. To calculate the amount of material remaining left, so the iodine 131 left, at first you have 100%, right? And then after one half-life, you take the number of tails and divide it by the original amount. And then once you do the second half-life, you take the number of tails remaining, which is even less, and divide it by the original 100%, and so on and so forth. So maybe you have 100 pennies, then you have 50 pennies, 50 over 100, then 25 pennies, 25 over 100, then 12 pennies, 12 over 100, then 6 pennies, 6 over 100. So that would give you percentages, and then you'd transfer those into your decimal points. That's how you do that calculation. Okay, then let's look at the analysis. When you come down to the analysis section, you will notice here is a link to the class data sheet. So this shows you the data for all of the students in the class. So normally you would put your own data on your own line. And then what you would actually do for the lab is you would fill out this second tab here where it says graphing data. So the class data is already filled out for you. I did not make you redo, copy it from the previous worksheet, but you do have to fill out the decimal percentages and percentage and decimal of the lab data that you got. And then also you have to fill out the theoretical amount that would happen. And once you do this, it will automatically populate the graph. So you don't even have to regraph it. So for theoretical, for example, I always start with 1. I should always start with 1. And then after 1 half-life, I'll have 50% or 0.5. And after 2 half-lives, I'll have 25% or 0.25, et cetera, et cetera. And just a little tip, if you want to know how to do formulas, you always start with equals, and then you can click in the cell of the variable that you want, and then hit divide by 2, enter, and it will automatically divide that by 2. Now, if I want this formula to just continue on and on and on, I'll click on the cell with the formula. You could tell it's a formula because there's a formula thing here. And then I'll drag it, this little dot, the blue squarish dot. I'll put my cursor on it till it becomes an X. No, not an X, a cross. And then I'll drag it down and it automatically calculates the theoretical half, 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 half. Everything is half. Okay, so then all you have to do is put your student data in and you will have the graph that is required for this second section here. Then down here, you can just pretty much answer the questions. I think they're fairly straightforward. Here's some calculation questions. Another just critical thinking question here. Write a conclusion. When you write your conclusions, you can just answer these questions here and that would be fine. And then last but not least, some post-lab questions. Your post-lab questions are just determining half-life. These are standard kind of Regents questions about practice about half-life. All right, so that's how you can do the half-life I-131 lab. Let me know if you have any questions.